So this is the second video of our two-part series on location of roots, a topic that many students find the most confusing when it comes to this chapter, theory of equations. Before watching this, please watch the first video because that one has 5 cases and this one has the 6th case and 2 previous year JE questions. If you have not watched that video, you might have difficulties in understanding all the different points of this one. So the last case is when one root is smaller than k1 and another root is greater than k2. Now for this one, the reasoning is pretty similar to the cases we have seen already, which is this case and this case. This one was the third case and this one was the fourth case, but the reasoning in all of these is pretty similar. First of all, let us draw all the possible cases or all the possible situations in this case. So one root is smaller than k1 and other is greater than k2. There can be two cases, a is greater than 0 and a is less than 0. So we find f of k, or we notice the sign of f of k at k1 and k2, and pretty similar to the previous two cases, that is case 3 and case 4 that I mentioned above. The overall condition is a times f of k1 should be less than 0, and that is an intersection of a times f of k2 is less than 0. Because it is pretty visible, when a is greater than 0, f of k1 is less than 0, so multiplying both we will get a value which will be less than 0. Similarly, when a is less than 0, f of k1 will be greater than 0. So multiplying we will get a value which will be less than 0. And as we have already discussed here, we do not need other cases or other conditions like d greater than 0, because if d is less than 0, then it makes no sense to have to say that one root is smaller than k1 or other root is greater than k2, because we have imaginary roots and we cannot compare real and imaginary quantities. As a side note, please don't confuse minus b by 2a to be the roots of any quadratic equation with imaginary roots. That is just the lowest point, or conversely that might just be the highest point. It has no connection with the roots. So I think people can get confused that okay, maybe we can make a case like this root, whatever this is, it's greater than some quantity, but that is not the root, that is the vertex. So as I explained in my previous video, in the third case, the condition that d greater than 0 or d equal to 0, it automatically takes care of itself. Similarly, in this fifth or in this sixth case, you have finally only these two conditions for one root to be smaller than k1 and other root to be greater than k2. So in this way we have covered all the 6 cases, and in every case, even though there are many possibilities of graph, that in I remember in all the cases we have seen at least 3 to 4 graphs, but those are not sub cases, that is just the possibility in a single case. So don't get confused that I have so many sub cases to remember. No, just remember the final outcome or the final set of conditions that we arrived at. And also, I'm repeating again and again, please focus on how these conditions came about. Please focus on the visualization as well, because it can happen that in the exam you are not sure as to what condition it is. So just remember how we focused on the value of f of k minus b by 2a and the value of discriminant, and visualize the graphs. Also, I have found that in some cases we have to see the value of minus b by 2a, and in some cases we do not have to. So if you get confused, let's say you are in your exam and you are not sure because you do not want to miss any case, right? Because then the values will be different, the final answer you will arrive at will be different. So just take out the condition of minus b by 2a, whatever you feel. For example, in this case, just take that minus b by 2a should be between alpha and beta, because in any case if you get extra values, they will get negated when you will take the intersection, because you do not take union here, right? In all the conditions of any case, you take intersection. So if you have additional values from an equation such as this one, they will already cancel out, or they will already be taken care of, because as I've told that in some cases we have to be very careful about minus b by 2a. In other cases we do not consider it as all at all. So if you are confused whether I should be focusing on it, just focus on it and find the values of x in the values in this case, and when you are taking the intersection, if there are some extra values, it will be already taken care of. Okay, so finally, let's just take some examples. Two previous year questions from IIT JEE. The first one is the smallest value of k for which both roots of the equation are real and distinct have values at least 4. First of all, let us identify the case. This is the very first case that we talked about when both roots are greater than k. Here k is 4. But remember, the thing here is at least 4. So we can have a root where alpha is equal to 4. So in one condition that we will arrive at later, we will have to take care of the equality as well. But let us start from the very basics. First of all, both roots are real and distinct. So very easily we should have d greater than 0. A is already greater than 0 because a is 1. So in this equation, we have to find d greater than 0. What is d? B square minus 4ac. It will factorize very easily and you will get k greater than 1. So that is the first condition according to that case, right? We had three conditions in this case. So the first case, d greater than equal to 0, but because we have distinct roots here, we remove the equality. The next thing is minus b by 2a should be greater than k, or k in this case is 4, right? K is the value, or k is whatever the value the roots are greater than. So in this case k is 4. Don't confuse it with that k in which is given already in the question, right? Okay. But in any case, so minus b by 2a, that is the vertex, should be greater than this quantity. So minus b by 2a should be greater than 4 from this condition. So again simplifying, we get k is greater than 1, which is similar to the previous case. Luckily, the answer comes out to be the same in both the conditions. And the final condition is a into f of k is greater than 0. But because in this case, it is given that it is at least 4. So 4 can also be a root. So you can have an equality here. Okay, in this example or in this question. So finally, a into f of k is greater than equal to 0. A is 1, k is 4. So f of 4, when you substitute 4 in that equation, you get these conditions. So k should belong to minus infinity to 1 union 2 to infinity. And from this one as well as this one, k should be greater than 1. So finally, taking intersection, we have k greater than equal to 2. So the least value, or the answer we required, was 2. So the least value is 2. That is the answer of this question. How simple. Because you know all the cases now. Otherwise, if you do not know, you will have to visualize the graphs and think which condition this might be. So because you have already read the theory now, you have already done almost more than half of your work if you have identified which case it is. Similarly, we had another question in JE 1995. Now, remember, when you see old questions, you might be feeling that, oh, these are so simple. But remember that back then, the theory which we are teaching you today, that is developed based, or we introduce it in a way based on those questions, right? So those students were probably not handed out these theories like, okay, there will be 6 cases in this on a platter. You are, because again, the theory that institutes teach you, or even the theories which we teach now, are based on these questions. Many of it is based on these questions. So these questions can appear to be very easy to you, but they were not back then. Now here we have one root greater than k2 and one root less than k1. So this is the same condition that we discussed in this video. The only condition which we discussed in this video, the only case which we discussed in this video, the question is based on that very case. So in this case, k1 is minus 1 and k2 is 1. So one root is less than minus 1 and the other root is greater than 1. So simply a into f of k1 or a into f of minus 1 is less than 0, and intersection a into f of k2 is also less than 0, or a into f of 1 is less than 0. So this was the question. This is the equation. Simple, a into f of minus 1 less than 0 and a into f of 1 less than 0. What is f of minus 1? A minus b plus c, and we just keep a as it is. Similarly, a into a plus b plus c. We open it. Now here we divide by a square. Remember, a square is always positive, so you can divide any any inequality by any positive quantity. So we'll get a square. AC by a I have written in this way because the answer requires you in this way. C by a minus b by a less than 0, 1 c by a plus b by a less than 0. And what is this quantity? Mod is plus minus 1. Technically it is when b by a less than 0, it will be minus b by a, and when b by a greater than 0, it will be plus b by a. But this is the way to write it. Now when this question was asked in IIT, it was a subjective paper, so probably they would have to show that what this case was, or derive the possibilities, or derive the condition in this particular case. But now it's an objective paper, so you don't need to show why this is. You can directly apply the conditions that we have taught you in case number 6. So in this way you can answer, or you will probably answer any question that comes from location of roots, which I again said that it is a very tricky, or let's say a confusing part of this chapter. And now, if you have watched these two videos, I don't think you should be able to find any confusion, or you should be able to not solve any question based on that. And the confusing part was when to take minus b by 2a, when to take d. As I've said, just take it in every case if you're not sure. If there are extra solutions, they will already be taken care of because you take an intersection in all those cases. So please subscribe to this page for more such value addition to your JEE preparation when it comes to maths. Thank you.